Hi, this is Paul again. In this video, I'm gonna call it No Chaos 5. In my last video, Chaos 4, I showed you the different types of AD and A rungs that you could get. And these rungs came out of the diagonals of the golden ratio rectangles. Now these rectangles are a very important feature because it's starting to show two-dimensional stuff. And it's plain to see the scholars love to be in 2 dimensions. I showed in my earlier videos that the Icosahedron rectangle and the Dodecahedron rectangle would line up on the same plane. I think this is a very important discovery for the last couple of months. So I think I'd better give it a nice front view. You can see in the center that I'm using a cyan size 6 Icosahedron rectangle. And I'm also showing a size 1 cyan rectangle. What's amazing about this is that each of these small rectangles line up perfectly with the icosahedrons. I also find that they make an excellent boss for lining the icosahedrons in the correct orientation. Now these icosahedron rectangles are sloping because the top and bottom edges of the rectangle line up with the top and bottom triangles of the icosa. So the geometry of these rectangles put together could be worked in 2 dimensions. Maybe one day you'll see it in the geometry book. Okay, something else. I'm gonna put a size 3 icosa in the center. Now look at the diagonals for the dodeca rectangle. They line up perfectly to the faces of the icosa. Isn't that something? Now I'm just going to show the geometry outlines. Now I show a size 3 icosa orange outline. Now look at the golden ratio purple size 3 rectangle. Now you can see the top and bottom edges of the purple rectangle line up perfectly with the yellow rectangle of the dodeca. Okay, let's take everything back and we'll just show the yellow rectangle and the cyan rectangle on its own. So in front we've got a size 6 dodeca yellow rectangle, and we show a cyan size 6 icosa rectangle, and we show a size 3 icosa purple rectangle in the center. Now when we hide the icosahedra, we show the icosahedra boss rectangle, which is a size 1. Now what's amazing about all these rectangles is that they're all on the same 2-dimensional plane. Okay, if you look in front, we have 4 different size Phi-Rectangles. You could think of them as windows and doors for an apartment block. Now if we keep changing the sizes of the doors and windows, the apartment block will go crazy. And they all can say that they built it using the chaos theory. Okay, let's get down to these sizes. Let's look at the purple rectangle in the center. Now look what happens when I move the first copy. You can see that it fits perfectly in the corner. And if we make another copy down, we get another good fit. So when we move a copy of that pair over, we get 4 of the size 3 fitting perfectly into the size 6 rectangle. Okay, I think I better show you some dimensions. I've showed this in earlier videos, but nobody was interested. We'll start by our first measurement. Now this is the length of a dodeca edge. This will be the length of the edge of a cube times phi. Okay, let's do the longer edge of that rectangle. We'll call this length db6b. And we can get this measurement by dividing the 600 by phi. Okay, let's check out the size 6 icosa rectangle. So let's look at the vertical edge first. This is a size 6 icosa, so we'll call it IC6A. Now this length works out to double the cube edge times phi. And you can see that we get ICB, the shorter length, by taking that measurement away from 1200. So you can see that the cube edge determines the size of any combination of icosahedron and dodeca. Now something else. Now look at the D6A edge. this edge is the exact same size as the size 3 purple rectangle. So you can see this is where the 1200 came from. And it also gives us the long length of S3. I can show it as IC3A. Okay, now we can go to the bottom edge. Now this one is going to be IC3B, which is the edge of a size 3 icosa. And we can get this length by just dividing by 2 the length of the size 6 icosa. Okay, now we just down to the last rectangle, the S1 rectangle. And this little anim shows that 3 S1s goes into an S3. So for this length we just have to divide the size 3 by 3. And to find the IC1B edge will be exactly the same. Okay, that gives us the length of the 3 types of icosas and also gives the length of the size 6 dodeca edge. So we've done the 4 basic phi rectangles. And that's what's given us 3D Platonic order. So you can see that basically what we've got here is that the size 1 phi rectangle is like a seed. Now each one seems to grow into a size 3 rectangle. And as you can see in front, it keeps repeating the same process and it keeps growing and growing. And it is just like when you throw a stone into a pond, you get rings growing. And I guess a mathematician could put perfect mathematics to all this. Okay, now I'll show the size 1 rectangles going along the diagonals of the yellow phi rectangle. Now notice how those little S1 rectangles line up perfectly. I show all the measurements in my lessons 1 to 10. Now you can see in front I show A1 and B1 and they are either side of the diagonal and it shows the edges of the size 1 a golden ratio. I show these measurements in lesson 10 and I show in earlier videos this setup gives us ZDNA. Now all this geometry is all on the same 2-dimensional plane. So I'll bring in the dodeca outline. So now I'll rotate it back and forth and you can see everything better. I think there's some beautiful geometry here and there's nothing to do with chaos. Now I'll bring in the size 1 icosetas and I'll rotate these 2 assemblies of icosetas for you to take another look. Now you can see the cyan diagonals are going through the vertices of the icoseta. Now if you look at the yellow diagonals of the dodeca, they are going through the center faces of the icosetas. Now the icosetas do not turn, so everything stays in the same orientation. That's what I think keeps your nose in between your eyes. And that is why I think the chaos theory is a load of baloney. Or maybe chaos is over my head. Okay, now I'll put a size 3 icosa in the center. Now look as I rotate it back and forth. You can really see how the icosetas are lining up to the center faces and to the vertices. Now I've got one more important feature to show you. I said that the icosa and the dodeca don't go center to center the faces, or the edges don't go center to center as it shows in the book. But sometimes the book can be wrong. So what I'm going to do now is bring in a solid dodeca. And now you can see it plain that the icosetas are not dead center to the faces. They are sticking out a wee bit. And I called this in my earlier videos the slimbo nipple or the slimbo gap. And if you look at my video lesson 8, I show all these measurements. I'll take the icoseta away and just show the rectangles and you can see it better. Now if you look at my earlier videos for BDNA, I show the slimbo and now it's essential in the geometry for BDNA. As I mentioned earlier on, if you build a huge block of apartments and use any size windows and doors, you won't need much brains to know that the apartment's going to give a problem. So anyways, this is Paul saying, thank you very much for watching my video.